Welcome again to another one of the Inform sessions that we're hosting every month. Today we have Lisa Kurowski, who's a Senior Business Analyst for NetApp IT, Services Management Solutions. And she will be talking about how NetApp IT has integrated the CMDB with OCI. That's the only introduction I'm going to give. Also that next month, we're going to have another Inform session, but this time we will cover Cloud Insights. So, and you will receive the invitations, and you will also have the invitations on the TPM newsletter that I send every month. With that, Lisa, I'll leave it to you to, if you can, please introduce yourself and start with the presentation.
Sure.
So, Elias, if it's all right, I'm going to jump in here first. This is Mary Jo LeBlanc. I work with Lisa. I'm the program manager for the NetApp on NetApp program here at NetApp, and that's basically it's a program where we talk about how we use our own products internally. We share those with customers and the lessons learned and the results and the benefits. Anyway, I had asked Lisa if I could just do a quick overview of how we use OnCommand Insight here at NetApp. And there's essentially three ways that we use it here for IT. And the first one is, and probably no big surprise for anyone, is we have our dashboards, and we use it for monitoring performance, capacity, all of those relevant storage metrics that we want to keep an eye on. So we do use the dashboards. If you go out to netappit.com, you should be able to download those dashboards. I'll put a qualifier on that I haven't checked that in the last month, so I'm assuming it's still there, but I'll check as soon as we finish here today and make sure that's there. The other way we do it is over on the right-hand side is storage as a service. We've had service level objectives based on IOPS, and we use OCI for that. And we classify our apps requirements based on these service levels of extreme, high, right, performance, and value. And then the third one, and the one that we're going to share today, is how we've integrated OCI with our configuration management database within ServiceNow. So I'm going to launch a real quick poll here first, just so we can gauge the audience. How many of you are familiar with ServiceNow? It's a U.S. company that provides service management software as a service, so it's a SaaS-based offering. And it offers a bunch of service management options. They have different modules. I forget how many they have. I think they have something like 50 modules. And they don't call them modules anymore. I think they call them apps. Okay, so we have a couple people out there that are not familiar. So Lisa, if you could take that into consideration as part of your as you start off here. We have a couple that are somewhat, so, and then we have quite a few that are familiar. So let's end the polling. I'm going to turn it over to Lisa and let her get started on basically a little bit of overview of ServiceNow and the configuration management database, and then how that's tied into OnCommand Insight.
Okay. Well, again, my name is Lisa Kurowski. I am a Senior Business Analyst in our Enterprise Service Management team. I happen to be IT's process owner for configuration management, and I also have within our team, which supports ServiceNow, across IT, I have responsibility for the configuration management database, discovery, and all the portal front ends to anything that automates things in our operational environment. And I kind of wanted to start here. I know that the end goal is to talk about integration between OCI and the ServiceNow, specifically the CMDB. But before you can do that, you really have to have a mature CMDB. So we're going to start a little bit with our journey with the CMDB and how it fits within ServiceNow before we get to the point where we talk about how and why it would be relevant to integrate it with OCI. ServiceNow is a SaaS application. We went to it as an IT organization probably 8 or 9 years ago at least, in order to solve operational issues within our environment. We really had a lot of instability in our environment, especially as it came to problems when we would introduce changes. So we implemented ServiceNow incident, change, and problem management to try to bring stability to our organization. And we followed that pretty closely with a service catalog, which gave a common front end for users to engage to IT. And very closely after that, we implemented our CMDB. And one of the advantages of this is they're all modules or applications within the ServiceNow platform, which then gives us the opportunity to do integration among those. But it is a standalone module or application that you can implement independent of incident, change, and problem management. The primary driver for us to implement the CMDB was consolidation of our production environment into a new data center. And, you know, again, before you can get to an OCI integration, you need to have a mature and stable CMDB. So our CMDB, we migrated off of a homegrown product that did not have good usage or access across our IT organization. It was not entirely accurate. It was not entirely complete. And so we knew that as a part of moving towards a single global production data center, we needed to have a solid view of what was within our IT organization. This is just a quick slide to kind of give you an overview of the scope and breadth of our current CMDB. If you're familiar with ServiceNow, then this concept of a CI, a configuration item, that is something that you'd put into your CMDB, would make sense. Classes are basically types of data that you would store, like an application would be a class, and every different type of server that you would store would be a different class. And then every individual thing you put into the CMDB is a CI. So we have around 195 classes or different types of data that we're currently using. To be fair, probably 30 or 40 of those are the ones that people use on a daily basis. And then others are things that we acquire as sort of supplemental information. We have around 2.2 million actual CIs in the CMDB, and we keep things from a historical perspective, like if I have a Linux server and I deprovision it, or a physical blade and I deprovision it, I keep that in the CMDB. Other things like the software that was installed on that server, I get rid of. So this is a pretty good representation of, for the most part, what's currently active in our environment. And then there's this concept of relationships. How do you tie those things together? Because having a great big inventory of your physical servers and not knowing what runs on it isn't really useful. And that's what a relationship does in ServiceNow, is it says the server is running this logical server, which is used by this application. We did our maturing sort of from a bottom up. Things that are in your environment that are physical are a lot easier to mature than the things that are in your environment, like Linux and Windows servers, which are things you can go access, but not things that you can stand with a clipboard and actually do a physical inventory. So our CMDB did mature sort of from a bottom up. Our data that came from our data center services team is very mature and seeded our system. When we implemented the CMDB, and as you move towards that, if you don't have one, a couple of our common principles were to leverage discovery and automated scanning as much as we could in order to maintain, especially those things that you can't actually touch. Do automation as much as we could have self-service as much as we could, and as a last resort, use, manual data maintenance. Manual data maintenance was really the number one way that we were maintaining the data in our old system, and it's another reason why that system was not as big a success. Okay, and if you have any questions, feel free to ask me as we go. So again, with the idea in mind that our CMDB from the outset really needed to be accurate and needed to have the least amount of manual intervention as possible when we implemented it using ServiceNow, we used quite a few peripheral features, one of which is the models database. So that allows us to ensure that any piece of physical infrastructure that we represent in our CMDB has a common profile. So anytime you look at a blade, it has the same characteristics. So we leverage the models database from our initial implementation. We also leveraged the service catalog features. So our data center services team uses a catalog to say, well, I have a new piece of physical equipment that's arrived on the dock, and I need to physically provision that. They can use the catalog. It will create tasks that need to be executed, and it's integrated with the CMDB so that as soon as they begin to physically provision that piece of equipment, it's represented in the CMDB and its states automatically tracked through. So it's really important to have that life cycle fully tied in to your CMDB. Same with the logical infrastructure that runs on top of that. We needed to be able to move very quickly to lift things from one data center to our new production data center. So from the beginning, we leveraged ServiceNow's catalog capability to integrate with HPOO for our back-end automation to provision Linux, Windows, and Solaris servers primarily. End-to-end, it would spin it up, do the OS installation, set up the groups. In some cases, they could order the installation of Oracle databases, the installation of MS SQL. We've since moved off of that. We've replaced our HPOO integration with WFA. And again, it's fully integrated with the CMDB. So when a user comes into the catalog and says, for this application, I need to order 3 new servers, it creates those CIs in the CMDB automatically, and they track through the life cycle. Okay, we also have bridged in the last 3 years off into the cloud. So that's more automation with some slight differences. We implemented the ability to do load balancer provisioning in the cloud. And we also did a much better lifecycle management because I think a lot of times we think about how do I get CIs into the CMDB? We kind of forget about the full life cycle. What happens when that physical piece of equipment decommissions? What happens when your Linux or Windows servers decommission? We kind of forget that we need to have life cycle operations tied in to ensure your CMDB is capturing things that go away. And that's probably our biggest mistake in our original implementation. It was all about moving to a new data center and spinning new things up. So a lot of automation to ensure that those CIs were automatically captured in the CMDB and they went live. And then we kind of forgot about the automation that was needed to eventually spin things down because it was all about build. So it's an important thing when you're working on your CMDB to ensure that you capture the end of the life cycle also. So we have automated decommissioning in our cloud.
Lisa, this is Mary Jo. So just for everyone, this always kind of this especially, maybe I'm jumping in a little bit ahead here, but it always looks a little complicated. But how long, I mean, you just didn't do this overnight, right? It took a while. And did you say you started with your data center, with the new data center?
Well, we did start with the new data center, but there were certain elements that we put in place that were across the board. So let's certainly we didn't do cloud up front, right? So there was an evolution in terms of some of the things that we did. It was purely an on-prem environment, but we captured all of our environments up front from a physical infrastructure perspective. And I'll show you a picture in a minute or two, how we leverage discovery. And discovery is focused on, in fact, I'll go ahead and use the next slide. Implementation from the beginning leveraged an integration with InfoBlocks. So InfoBlocks is giving us the subnet mapping of our IT global data centers. We can use that to scan the environment and find all of the logical infrastructure that's in our environment. And from the beginning, we did a lot of things, including the models, the naming conventions that will allow us to tie things together. But we really did have a very solid first implementation, because that first implementation really did already have front-end catalog integration for tracking physical infrastructure. So as new devices, new equipment arrived on the dock, it was immediately captured in the CMDB when they would begin to provision it. And same with the managed hosting on-prem landscape management. The vast majority of that was done through the service catalog, and those CIs were automatically created. Now, as we spread out and begin to look at maturing network data, maturing load balancer data, maturing storage data, those things came second, and it was an evolution. The other evolution is you start with having something that becomes relatively mature before you then begin to leverage that in other ways, right? So integrating that data into your incident and change management, so that when someone calls up and says, I have a problem, this piece of physical equipment has just failed, what is impacted, right? Well, if you have a mature CMDB, you could put that physical CI into the ticket and have it come back and tell you which applications and business services are impacted. Same with change management. You could say, I need to patch these servers. Which applications are going to be impacted, and who do I need to provide approval? These things are next generation, right? Once you have a reasonably sound core CMDB, you can begin to leverage that CMDB in other integrations, including incident change management, including things like monitoring, but also including OCI. So it's really important to build your CMDB, think about the entire life cycle of the CI before you try to tackle OCI integration, because that OCI integration needs, in order for it to be really successful, to have a relatively complete and accurate and dependable CMDB to be integrating with. Okay, so once you have that core CMDB, you can extend and expand what you can integrate it with, inclusive of OCI. So this picture, is a bit complicated because it has so many boxes and lines, right? But it really represents the infrastructure that every company has, right? Down at the bottom, we have our physical representation of our data centers. And each box basically represents a class of data. In the CMDB, every line represents a relationship, and that's how you tie the things together in a ServiceNow CMDB. So these are our data centers broken down into data rooms, broken down into zones which have racks. This data is owned by the data center services and is relatively static. This layer is your physical infrastructure. So all the different kinds of physical equipment that we have in our environment, again, it's owned by data center services. It has a front end of a service catalog, so that these CIs are automatically put in to the CMDB as they work through that physical provisioning process and are tied together by data center services. Okay, this green layer here is really the biggest layer. In fact, it probably covers 90% of the data that's in the CMDB. I didn't even try to put all the types of data that can be captured here. And this data, this layer is really made up of two things: data that is automatically discovered or put in there through the front end catalog. So when we provision a Linux server, that Linux CI is put into the CMDB on order. As it goes through the provisioning process, it changes state, and then when it's fully spun up, we discover it. That creates a whole bunch of more data, right? Like what's running on it, what software is installed, what mount points does it see, what IPs does it have, what network adapters. So there's a whole bunch of additional data that is behind each one of these. From a maturing perspective, if we look at this path right here, application to server, logical server to the physical asset to the data infrastructure, this would be the first path that we took to mature. This is the data that you really need to have in order to do an integration with an OCI. You need to know what logical infrastructure you have, and you need to know which applications are using it. Okay. Again, automation is your friend. The automation that we put in place, because who has time to create all these connections? It's going to be inaccurate if it's done manually. So we leveraged the power of discovery to give us the serial number for any logical asset that can be discovered. It will tell us what its serial number is, and we use that to automatically create a relationship with this physical. So data center services ensures that they capture the attributes of the physical infrastructure, including the serial number, when they put it in. And then we can leverage the fact that these CIs down here in the yellow layer are going to have the same serial numbers as what's discovered in the green layer and automatically create those relationships. We don't have people running around trying to figure out what those relationships are. And we'll look at a picture in a minute for virtualization, right? There's technically could be more complexity to how this works, right? A virtualized Linux server is going to run on a hypervisor, and it's really the hypervisor that's going to connect here. Discovery helps us do that as well. Okay. The second layer of connectivity that's really important is upward to the application. So it's great to know all your physical infrastructure, and it's really important to know what's running on the physical infrastructure. But then it's really important to know what's using that logical layer. And we create this connection here in a couple of different ways. The first is that when we provision it, we've automatically identified which application you were building it for. So it's kind of easy to create that connection. But we implemented a naming convention from the beginning that any application that's registered is assigned a 3-letter code. That 3-letter code is embedded in every server name that we provision. So our automated provisioning enforces some naming conventions. So if anything is built out of process, as long as it follows the naming convention, our full scans can come along and find it, and we'll still create and maintain this relationship. Okay. Again, with that theme that, you know, people will always ask, how mature is your CMDB? And the question is always relative to time, right? In the beginning, the most important thing was to figure out who really owns all these applications. This actually was probably a 6-month exercise just in and of itself, trying to get the level 2 application teams to really specify which applications they owned, which ones were P1, which ones were SOCs, and getting them to really own this data so that we could put our global service desk to using it. So now they can use the CMDB when they have a P1. We get a ticket that says this application is down. we have an accurate place to go and get contact information. You can look at that application and see what infrastructure it's running on, right? And cascade down. So this is the core path of maturity that we originally took, and then we extended out into network, and we've recently been working on the load balancers. So the F5 load balancer is the primary technology that we use. We've created some customization that allows us to tie the applications to the load balancer services based upon pool members. So the IP of that pool member is going to match something over here. And since we know what these relate to, I can create relationships between load balancers and the applications. Now, an application owner can know what infrastructure they use and what load balancers they own. Okay, the last big thing in this layer, which is really important, is all this storage. So we found that ServiceNow's ability to discover storage was weak. The most important weakness was its inability to create this connection here. So again, having an inventory is good, but it's not what you really need to run your operations if you can't tie it back to your infrastructure and your applications, because then an outage or the desire to do chargeback or service reporting is all hindered by the fact that you don't really know who's using it and how important it is. So if you have an outage with an application that is not critical to your everyday business, you don't want to treat it with the same level of importance as an application that is a P1, Tier 1 application, where if it goes down, you have an immediate impact to your business, even exposure to your customers. So we needed the same thing for storage. And so everything that you see here that starts with OCI, and I don't know why that one says OVI, we'll fix that, is imported from OCI. And we did this integration only after we were fairly confident, that this data over here was going to be mature. So the integration point is going to be by IP, because we're confident that the IPs that OCI has, that you're doing storage exports to, are going to match up to our inventory of logical infrastructure. Okay, and this picture doesn't look a lot different. This is our traditional, kind of 10,000 foot level view of our traditional data center, as well as private cloud. We are doing public cloud also. It looks, relatively similar, except that, of course, we don't have the responsibility for the physical infrastructure or the hypervisors that these run on. We do maintain ownership of our storage. So anytime we do a public cloud hosting, we have our storage also in a public cloud location, but hosted on infrastructure that we maintain ownership of. So we can switch from one public cloud provider to another by simply changing where this server is residing, but this is our data and maintains our ownership. So just bridging a little bit more into the OCI integration, we really had a couple different types of OCI integration that would be visible on the CMDB side. The first is that this idea of relationships that we saw here, right? Downstream from a server is going to be something, right? It's either going to be physical infrastructure or it's going to be the storage. So ServiceNow represents that as a downward relationship. Upward from, this is a Windows server, upward from that Windows server is going to be the application, and downward is going to be the storage. So if I were to go look up a particular server in the CMDB, and it would give me, and this is kind of fake data, right? It would give me the server name, and it would give me the IP address, and a lot of information that I get through discovery. But it would also show me the downstream relationships to the storage. Okay, and the other thing is that We populate a custom field for the OCI asset URL. This is a URL that takes us directly over to OCI. So when we have an outage and we're determining whether or not we think storage might be a part of the impact, we can simply click on the URL. It takes us over to OCI, and we can immediately check the health of the storage associated with that server to rule it in or out as a part of the solution. If we like step up a level, this is a BSM diagram. It is a visualization tool that ServiceNow gives you. It doesn't go this deep. If anybody's using ServiceNow, you'll know that I took some liberties to kind of glue together a couple of views. If I were to really do this for a server, there would be a lot more storage associated with it. And then this diagram would become too busy. But basically what ServiceNow does is represent each of your CIs as a circle, and each of the relationships is a line. So this one is centered on this virtualized Windows server, which I can tell not only by its name, because we name all of our VMware virtualization servers, they all start with VMW. So I always know this is a VMware virtualized server. It's running on a hypervisor. It's running on a physical server, which is tied into the rack. The ESX has some of its own storage. The Windows server has some storage that it's using for the application, to host that application, right? So it eventually is going to try back to a controller in a rack. And upstream from that is got kind of tinier, is going to be your application. And we have created as well relationships up to our business services. So here you can see the integration from a visualization perspective. I can see what storage it's related to, and with ServiceNow CMDB, I can click on anything on the screen and refocus the diagram. So if I want to see everything that's tied into this rack, or I want to see everything that's hosted on the server, or everything that's running on this ESX, I can do that. Okay.
Lisa,
And if they were to,
it's Mary Jo. So on this particular diagram you have up there with the circles, is this something that was created by the CMDB? I mean, this relationship, all this relationship and tracking, or
yep.
so it's something.
So
how did you do that? I mean, how did?
Well,
Go ahead.
let me see if I. So this little icon right here is the BSM diagram icon. If I'm on a CI and I click on that, it is going to give me a picture similar to this. The look and feel has changed with each generation of the ServiceNow UI. These are less colorful in the current implementation. They're just all green or whatever skin coloring you've chosen, but it is basically going to give you a visual representation based upon the data that's in the CMDB. So if this relationship doesn't exist, it's not going to show up on the BSM diagram.
Gotcha.
Right?
Okay.
So you can use to run up and down in the CMDB. You know, different users have different interests. Data center services is more likely to come into the CMDB and be inspecting this data and say what's up and what's down from where I am. The command center, which runs our operations, more likely to come in at this layer, right? And to look upstream and say what application, what's downstream, what storage, what physical infrastructure. The application primes are most likely to come in to the CMDB at the application layer and say what's down from me. So regardless of which CI you select, when you get to the CI, it always tells you what the class is. So I can tell this is a Windows server, or I can bring up the application, and it's going to show me what's downstream and what's upstream. I had to cut it off because this got way too small, right?
Understood.
But there'd be a whole list of the downstream relationships. And if I click that little button, it's going to pop me a BSM diagram. And again, I took some liberties to glue together multiple views because this volume is not the only thing off of this internal volume, right? It's not the only thing off of this OCM. So we wanted to be able to see in this picture a clear path that what the CMDB is providing you, right, is the ability to connect from the very top of your tree what business services make up the capabilities of your company, which applications support those, which applications are supported on what logical infrastructure. This is a virtualized environment, so I can use my CMDB to say, you know, how many hypervisors do I have, which servers are running on which hypervisor, what storage is leveraged. I had to glue a couple, you know, I basically had to go in and click on a couple different CIs so that I could see their up and down and glue them onto one sheet. But I could do this
by
if I wanted to, right?
Okay. Yep. So a BSM then is a business service. I'm assuming BSM, the acronym stands for Business Service Management or something, or mapping. Maybe it's mapping. I guess it's mapping. Never mind.
Right.
I just put that together. Okay.
Yep. If you hover over that little icon, it will say BSM.
Gotcha.
And you can click on it, and it will pop you up a visualization of the data that you're currently looking at. And you could tell it, I'd like to see 3 layers. So it's going to give you 3 layers up and 3 layers down. Or you could say, I'd just like to see 1 layer up, 1 layer down. You can click on any one of them and say, I'd like to redo this visualization, but I'd like to do it from the ESX. It could get kind of complex, right? I mean, if you have 30 servers running on the CSX, it's going to be a complex diagram, right? But it's another way to look at the data. It's another way to navigate up and down.
Okay, cool. Thanks.
Okay, sure. And I think the last slide that I had in there was just what happens if you go over to OCI. So we have been working on reverse annotation of the OCI data as well. So what that means is that we not only pull the OCI data over to the CMDB, so that from the CMDB I can see what storage each server is potentially using, and I can see which application is using those servers. But we're also pushing some of that data back over to OCI, and you can annotate OCI to say this particular asset, right, is associated with 1 or more applications. In this case, it was just used by the 1, because your storage people are probably going to use OCI as their primary day-to-day tool, whereas the command center and your operations folks are going to be over in the CMDB. And so both have a consistent view of where and how this storage is utilized.
Okay, cool.
Okay, so I guess a couple of common themes is the OCI integration is going to require that you have maturity in your CMDB, so that obviously when you bring this data in, you have something dependable to connect to. And maturing your CMDB is an effort in and of itself. From lessons learned, the more automation you can use, the better off you'll be. And think about the entire life cycle of the CIs, because we kind of forgot about that decommissioning portion. We were so intent on building up the environment and transitioning, kind of forgot about the fact in the beginning that, you know, eventually applications do retire, servers go end of life. And so you have to think about the end-to-end life cycle of your CIs.
Okay. So Elias, I'll let everybody on the call know we do have another presentation that goes further into in more detail on our automation ecosystem and all of kind of the players that we use for monitoring and monitoring for tooling and for tools. And so please let me know if you would like to put that on the agenda, because we'd be happy to talk on that subject.
Okay. We can discuss that in our next call, probably.
Mm-hmm.
Okay, and then I can actually ask the question out to all our partners.
Okay.
So I guess now is a good time to see if there are any more questions. We can go into any portion of the actual integration or anything else that we did to mature our CMDB or automation.
Has anybody got any questions for Lisa?
Is there a demo for integration, how we do it? Because we are currently in the process of implementing ServiceNow. So it's the right time we want to go for, so because then it will be very easy for us.
So I can't actually demo it now. We have two types of integration that is offered. One is a simple plugin, and the simple plugin is free, and it basically wouldn't provide all this level of complexity. It basically is just going to provide connectivity between the the logical servers and your storage infrastructure, and kind of mask all of this. You know, we kind of went for the whole enchilada when we first implemented it. The goal is not to replace OCI, right? Or to push all of the OCI data over into the CMDB. And to some extent, we might have pushed more data than is actually needed. What you really need is to connect, right, your logical infrastructure to your storage at a level that is sufficient that would let you help understand what those dependencies are. And that plugin is relatively simple to use. It creates the tables that are required and uses the IPs that it gets from OCI for what the file shares and volumes are exported to, and uses the CMDB, IP, and server data to create connectivity. It takes multiple passes through that. The other connector actually creates connections that are more complex, like this one, and I think you've got to go through professional services in order to get that and to use it. We're using our original custom implementation as opposed to the connector that we now offer to the customers, but that connector is based upon what we did here.
Okay, thanks.
Okay, but again, you're going to want to get this mature. We did not try to do this integration for probably 18 months after we implemented our CMDB. And that's probably twofold. One is it takes time to be mature, but of course, keep in mind that our original focus for the CMDB was migration to a new production data center. So that bringing up that new production data center, getting that entire environment built out was our #1 focus. And then later we came back and began to mature other things to say, well, like we're missing this whole storage piece, right? So we didn't do that for about 18 months after we built it. But again, that had a lot to do with the fact that our primary focus as an IT shop with the CMDB was migration to that new data center and building up all of that infrastructure and getting that data center operational. And
Lisa, could you cover one more time how, I think it's on the next slide, how this works with the hyperscalers, the public clouds like AWS? There's a question in the chat window wanting to know if we also pull remote cloud assets, say from AWS into our system.
Well, our cloud, we have a cloud implementation right now is based upon ServiceNow's cloud management platform. The ServiceNow cloud management platform has a discovery mechanism that can scan AWS. AWS is the only one that we're actively scanning using that technology. So it will, I mean, there's a level that it won't go below. You're not going to find the hypervisors that Amazon's using because in a way, I could say either they're none of our business or you could say it's irrelevant, right? What's really relevant is what assets you own. It will scan the virtual servers, and I'm trying to remember if it scans the ELBs. It does scan the ELBs. It scans the load balancers as well. So this data can be populated in our CMDB through ServiceNow Discovery. We've not tried to use it against Azure. Azure, we are doing more of the traditional scan where we pull from info blocks the subnet that is associated with the subnet at Azure. That's effectively ours, right, to spin assets up in. And so we find our assets. We find our assets that way, and we then leverage the naming convention to create connectivity between applications and the infrastructure. We are in the process of building another implementation of infrastructure as a service that will eventually be able to provision at private cloud, Amazon, Azure, and Google. But there's no need to go below, this layer. But you can discover, the virtualized servers that you've provisioned, and I'm not 100% sure we're going to continue to use ELB at Amazon. I think there's some discussion about it supporting something more similar to an F5. I'm not sure what Amazon calls it, but I think from a technology perspective, our next iteration of load balancers will probably not be the ELB. It'll be something else. Did that answer the question?
So, yes, thanks. Okay, very good. Well, as Elias mentioned earlier at the beginning, we'll be back again next month, and the subject's going to be Cloud Insights. We've started to use Cloud Insights, so 3, 4, 5, maybe 6 months ago. We have about 90–95% of our storage footprint already being monitored by it, as well as some other things. So we'll be back and to talk about that. Oh, one more question. Do you use implementation to provide cost analysis and chargeback, or purely for reporting management and orchestration?
So there are a couple different questions in there. So cost analysis, our IT Office of the CIO has taken a couple of different swags at that. CMDB data, it was given to the Office of the CIO. They were leveraging an ITBM tool to do total cost of ownership calculation. We're not doing chargeback of private cloud or managed hosting. We do chargeback of public cloud, but we have to leverage, we're going to pass back the cost that's actually incurred. So if you spin up a server at Amazon and then you don't shut it down, but you suspend it, it will reduce your bill for that month, right? So we actually leverage the CMDB data to understand how to partition up that bill, if that makes sense, right? So we're not trying to generate our own chargeback model, but we can take the bill from Amazon and use our provisioning process will annotate any of the assets that we provision there with the cost center that we want to bill that back to. And so we're not using it to actually issue the bill. I hope that makes sense, right? We can use it to partition up the bill, but we didn't tie it into like our financial systems to do an automated chargeback.
Right.
Next generation, we are moving in the direction of a showback initially for both private and public cloud. We'd eventually like to move towards chargeback of everything, but right now we will simply, maybe the right word is pass back, right? We will pass back the values, pass back the cost associated with hosting something in the public cloud. Eventually, we would like to partition IT's costs and do an actual chargeback for private cloud hosting also.
Hi, Gavin,
so the number one, go ahead.
I was going to ask Gavin, this is Gavin Jarrett, I think he asked the question, but maybe he's got problems with his communications with the phone. Just ask him if you had answered his question.
I see. Cool. Thanks.
Yeah, that means a yes.
Yeah. Yep. Yep.
Okay.
It's always hard to get, to the point where you do an actual chargeback of IT internal services, right? The easiest pass back of services is going to be for something that's in the public cloud, which is driving cost over and above the run rate of IT. So it's been our goal for 2 or 3 years to look at show back and eventual chargeback of things like managed hosting and private cloud. But public cloud's where it makes the most sense because it is over and above the run rate cost of IT. So we do pass those back, but not private clouds yet.
All right, one last call for questions. All right, Elias, you can wrap up here.
Yeah, okay, so we're going to close the call. Thank you very much for attending. And thank you very much, Lisa and Mary Jo, for hosting this webinar. As Mary Jo informed you just a few seconds ago, we have another call on Cloud Insights at the end of June, and I will be sending you the invitations. I think it's on the 27th.
That's correct. Right. Same time on the 27th. And then I think right now we're planning to do flex groups in July.
Okay. All right.
How we're using flex groups.
Okay. So thank you very much, Lisa. And now I'm going to go and get myself an enchilada because you mentioned that and I've got that picture in my head.
All right. Thanks, everyone. All right. Good day.
Thank you.
Bye-bye.
Bye-bye. Bye.